Irus is a centrally controlled energy management system for multi-occupancy dwellings, such as student accommodation. It comprises a master interface unit situated in or close to the comms room, and secondary interface units situated in designated electrical riser cupboards around the site. Each room requires a control unit, a power unit, a key-switched fuse spur, and the heat source, electric heaters or wet radiators. If wet radiators are installed, a valve actuator is also needed. The master interface unit sends and receives information and instructions via the secondary interface units to and from each room, using the site's existing electrical wiring. This is known as mains-borne signalling. Equipment connected to the electrical circuit in the building places a tiny signal on the earth and neutral wiring. Tones are transmitted along the wires. These are like two very high-frequency musical notes. A receiver on the circuit detects these tones and decodes them into the ones and zeros that make up digital communication. The same principles apply if Irus is connected to water heating control, leak detection, hop sensors, or any other Irus product. Energy managers view the Irus portal via the internet and can monitor individual rooms and hot water tanks. Profiles can be set, temperatures and times adjusted, and alerts are sent about unusual environmental conditions such as water leaks and CO2, humidity, light and decibel levels without having to enter the room. This is how Irus is configured. The secure portal displays the data collected by the master interface unit. The master interface unit uses either the site's existing data network or Cat5 cable to send and receive data from the secondary interface units, which in turn communicate with the room's control unit using mains-borne signalling. The control unit controls the heat source in the room through a power unit. Modules within the control unit monitor the room's environmental conditions. Data collected by the control unit is transferred back to the master interface unit in the same way but in the opposite direction. To ensure reliable communications throughout the system, it is essential that wiring is firmly connected at all terminals. Particular attention must be paid to the consistency of the earth line. There are separate videos explaining how to install electric heating, wet heating, hot water control, and leak detection sensors. All wiring should be carried out by a competent electrician working in accordance with current regulations. Identify the appropriate power supply and perform procedures to ensure the circuits are completely isolated. The supply should be locked in the off position, and safe working practices should always be observed. Our retrofit water tank kit contains all you will need to control an existing twin-element hot water system, except for 2 double-pole switches for isolating the control equipment from the main supply. The kit comprises the control unit, the power unit, the slave relay unit, the probe interface unit, tank probes upper and lower, 2 3-meter red and black patch leads, and 1 300mm patch lead, and thermal paste. The control unit has a screen, a PIR motion sensor, and up and down buttons. These buttons also enable you to find the control unit's serial number and test the elements. The power unit provides the control unit with separated extra low voltage, or SELV, and a 16 amp switching capacity. It has a red active LED that lights when the heater is drawing current, and a green power LED to show that power is reaching the unit. The slave relay is a second relay output, and when used in conjunction with the power unit, provides the control unit with the use of 2 16 amp relays for switching twin-element hot water tanks. The probe interface unit is a link between the tank temperature probes and the control unit. For maintenance or replacement of components, double-pole switches are essential for isolating the elements, power units, slave relay, and control unit. The control unit is an electrostatic sensitive device, and therefore care should be taken not to touch the printed circuit board. Throughout installation, ensure all terminals are secure, but do not over-tighten. The control unit is 85mm square. It is a standard single gangplate size and requires a 25mm deep surface patras, dry lining plastic box, or metal sunken box with 2 mounting points. If they have 4 lugs, remove the top and bottom ones. The power unit, slave relay, and probe interface unit dimensions are 146mm by 85mm, and they are a standard double gangplate size. They require a 35mm deep surface patras, dry lining plastic box, or metal sunken box with 2 mounting points. Wiring the elements. The live wire from the bottom element connects to the power unit's load terminal. The neutral and earth wires connect to their respective load terminals. Use 3-core cable to connect the power unit to the appropriate isolator, taking the isolator load live to the live on the power unit, and the neutral and earth wires from the isolator load to the neutral and earth terminals on the power unit. Use the same process to connect the top element to the slave relay and its isolator. Connect the power unit to the slave relay using the short RJ45. On the tank, set the element's own temperature thermostat to 60 degrees C. This is so that it doesn't interfere with the Irus control regime. To achieve this, ensure the element is isolated, then remove the cap which exposes the internal thermostat and adjust the dial to the manufacturer's setting for 60 degrees C. Preparing the tank. The tank needs to be prepared to accept the probes. This requires a 44mm hole saw, tape measure, and a wire pencil brush. The tank probes must not be fitted within 200mm of the nearest edge of an element. The centre of the probe should be level, with the uppermost point of the element. The top and bottom probes should be vertically aligned. If the tank has a steel or plastic jacket, use the hole saw to bore a 44mm hole. Be sure to only drill through the outer jacket. Stop when the outer jacket is cut. Remove the pilot drill from the hole saw and then turn it by hand to gently cut through the insulation on the tank wall. Stop when you feel the teeth of the saw touch the metal side of the internal tank. Remove and discard the insulation from the hole saw. Use a cleaning tool, such as a handheld wire pencil brush, to remove any insulation residue left on the tank surface, ensuring it is clean. Fitting the probes. The red probe goes in the upper bore and black one in the lower bore. The labels on the probes should be upright to ensure they are correctly orientated. The RJ45 cables should be able to hang down through the slot on the underside of the shaft. Check the depth of the bore with the barrel of the probe. If the barrel is too long, this can be sawn off to size. If the tank has a steel or plastic outer jacket, clean the surface where the probe will attach with an alcohol wipe. Secure the probe mounting flange by removing the backing paper from the sticky pad. Then bend and press the flange flat against the curved surface. If needed, use the 4 self-tapping screws supplied to provide the flange with additional fixing strength. If the tank has a padded jacket, use ratchet straps to secure the probes. Use the hooks on the flange to hold the straps in place. Fit the straps around the tank's body only, ensuring they are not wrapped around any pipes or other obstructions. Do not over-tighten the straps. The thermal paste in the syringe should be applied to the copper head of the tank probes before they are inserted into the bores. 1 mm across the whole surface is the optimum amount. It is important to have consistent coverage. Applying a greater depth of paste will not improve performance. Insert the probe sensor through the upper mounting flange and push until you feel the copper head meet the tank's surface. Use the ratchet to ensure the spring is compressed. Repeat this process with the lower sensor. Using a standard 6-core low-voltage alarm cable, connect the control unit to the power unit, ensuring the coloured wires going to the terminals match. White wire from terminal 1 on the control unit to terminal 1 on the power unit, blue terminal 2 to 2, green 3, yellow 4, black 5 and red 6. The length of the data cable should not exceed 6 meters. Do not use a solid core data cable. Ensure all terminals are secure, but do not over-tighten. Use low-voltage alarm cable to connect the control unit to the probe interface unit. Connect the EXT terminal on the probe interface unit to the EXT terminal on the control unit. Likewise, the therm terminal on the probe interface unit is connected to therm terminal on the control unit. Remove the knockouts on the base of the probe interface unit. Use the red RJ45 patch lead to connect the upper probe to the probe interface unit, and the black RJ45 to connect the lower probe. Secure the cables with the clamp on the probe interface unit. At the probe end, use the 4 loops on the flange to secure the probe cable tidally with 2 cable ties. For a single element tank, the procedure is the same as described, but with the omission of the slave relay. Ensure the water tank is full before testing. The installation can be tested using the control unit. Hold down the up button and then press the down button 3 times in quick succession. This puts the control unit into test mode. Press the down button 1 more time to enter test mode L2. This will turn the lower element on. The screen will indicate amps being drawn. Only test if tank is filled with water. To test the upper element, press the up button twice. L1 will now display, and the top element will switch on. Likewise, amps being drawn will be displayed on the screen. It is important that the control unit is commissioned as soon as possible after installation. This will ensure minimal disruption to the users of the tank's hot water. When the control units have been installed, the master interface unit needs to identify each of their locations: the block, the floor, and the tank it is controlling. It is essential that this is done accurately, so we know that we are controlling the correct tank. A location list will have been drawn up prior to installation. What we need from you is the serial number of each control unit and which tank it is controlling. Each control unit has a 5-digit serial number. To find this, press and hold the down button, and then press the up button 3 times in quick succession. The serial number will appear on the screen. Do not confuse this with the manufacturing number that is printed on a label applied to the back of the unit. The number on the screen is what we need to assign to the tank, so we can begin our commissioning process. You should log the serial numbers on an Excel spreadsheet. We can provide you with a template for this if required. It cannot be stressed enough how important it is that this information is recorded accurately. Any mistakes or omissions will result in a callback to tanks that have been incorrectly logged.